In this video, I'll explain the basics of Java Naming and Directory Interface, or JNDI. JNDI is a comprehensive API for looking up objects by name or by their properties. It's designed to be implementation independent, so it will work with many different naming and directory technologies. One of those naming and directory services is provided by the Java EE application server. You can use JNDI to access all of the resources, services, and objects that the application server provides to your application. The basics of JNDI are very simple to understand. First, you need to understand the two main concepts, naming and directory. So what's the difference between these two? Well, naming refers to a simple mapping between names and objects. For example, my name is Ben, and when I usually hear the name Ben, it refers to me. In the same way, in an application server, the configured services are accessed by name. So if you want a connection to your app's shopping cart database, you request it by name, such as shopping cart. Directory lookup refers to searching by attributes. So if I'm at a party with many people, an example of directory lookup could be to look at the list of invited people and to find my name Ben by searching for males who live in Sydney and work at UTS. On an application server, directory lookup is most often used to provide integration with an organization's directory lookup services, such as access to a staff directory or username passwords checks. Let's look at each of these in code. First, we'll start with naming. Here's an example of accessing a database connection pool by name. You can see that we call initial context.lookup. The initial context refers to the base of all JNDI queries. JNDI allows subcontexts that work like directories, but if we just use initial context.doLookup, it allows us to find an object by name directly. In this case, the database connection pool is named JDBC/AIP. This name, JDBC/AIP, was configured inside the Glassfish administration console. I added a JDBC connection pool to the resources, JDBC resources settings. Now, once you've got a data source, calling getConnection will retrieve a connection from the connection pool. You can use JNDI to access any resource that's been configured in the application server. For example, in the Glassfish administration console, I went into the JNDI custom resources and configured a string constant named resource/subject. From the code, I can get the value of that constant with just one line. As another example, Glassfish allows you to configure a Java mail session. Once you've set up the mail server properties in Glassfish, you can then send an email from your application in just a few lines of code. There really isn't that much to JNDI naming. Just set up a resource in your application server, and then in just one line of code, you can access that fully configured object ready to use. Directory is a little bit more complicated because you can perform more sophisticated searching. And here are a selection of the kind of services that you can query using JNDI. DNS stands for Domain Name System. This is the service that maps names like uts.edu.au on the internet to the underlying IP addresses that are used by the network to route data packets between client and server. LDAP is the Lightweight Directory Access Protocol. It's often used inside large organizations to store internal user, account, and system configuration information. And this is what makes it possible for you to use the same username and password on the library website, on UTS Online, and in the computer labs. COS naming is used by the Corba Distributed Object Protocol to store object references. And RMI registry is similar, but it's used by Java's remote method invocation protocols. They're lower level network communication technologies, but you don't need to worry about them now. Finally, NIS is a Sun Microsystems technology that was also used to store host and user configuration information, but now it's mostly superseded by LDAP. But all of these are available within JNDI. So let's go back to the code. Now, JNDI is a general purpose protocol, and we can use it even without an application server. This is an example of how we might use JNDI to do advanced DNS queries in ordinary Java code. Note that you first need to create an initial directory lookup context, then you fetch the attributes of the domain name, and then finally retrieve the value of a particular attribute. Here I'm retrieving the MX or mail exchanger record, and this will find the IP address of the university's email servers. Okay, that works, but it is a little bit more complicated than it needs to be. If we're running on a Java EE application server, we can move all of that configuration into the container. So I can go into the server's administration console and set up the DNS directory service as a JNDI resource named resource/DNS. So this slide does exactly the same as the previous slide, but this time there's no configuration because it is all managed by the application server. We can use JNDI to do LDAP lookups. Here, I'm querying the UTS staff LDAP server to get the email address of the staff member who has staff ID 107624. We can also use LDAP to perform searches, such as searching for all staff with the surname of Johnston. LDAP can even be used to authenticate passwords. This is handy when you're developing internal systems for large organizations, but it's beyond the scope of this subject. Just like before, we can move all of that configuration code into the application server so that our domain logic is clean and simple like this. Now, so far we've been using global names. When we configured the database, we gave it the name JDBC/AIP. So it's accessed by the name JDBC/AIP, and anything that uses the name JDBC/AIP will get that database we've configured. So the name's global. The same name refers to the same thing. Obviously, this is a very simple and logical way to work. But can you think of any situations that this could cause problems? Well, normally there isn't a problem. As a developer, you can choose a name, and in our application server, we can just configure that name any way we want. If you want your system to use a different database, then you just reconfigure the database. But here's the problem. What happens if you want to deploy the same application twice? You might want one deployment to be for testing and the other for production. Since the application is the same, then they must only refer to the one resource, unless we can deploy them on completely separate application servers. There's another problem. What happens if we have two separate applications and they're deployed on the same server, but the developers were different groups who happen to use the same name to refer to different databases? If they're using global names, then that same name can only refer to the same object. It turns out that Java EE provides local JNDI names to solve this problem. Rather than needing to change the code, the application server refers to its resources by a local name. These local names are then mapped to global names by a deployment descriptor. So in this example, the application uses the local name java:/env/jdbc/jdb. And the application server maps this onto the global name of the JDB's resource, jdbc/AIP. This java:/conf/env is a local resource reference. You could read it as the Java component environment. This is the private environment for the component that you're coding. You can map from this local resource onto an external resource using an XML deployment descriptor. That is, in your project, you can add an XML deployment descriptor that relates your local JNDI lookup into the global JNDI name. Once you've done that, the local name can be used anywhere in your code and then will be mapped onto the global JNDI resource. So to summarize, JNDI supports naming and directory services. Naming maps from names to objects, whereas directory services allow you to search and retrieve attributes of objects. In Java EE development, JNDI is the main mechanism for accessing services of the application server and for querying LDAP-based directories. I'd like to finish with a question for you. The API provided by JNDI is fundamentally string-based. All the names and queries are written using Java strings. But in good programming practice, using strings as identifiers is often looked at with suspicion, because there's no way for the compiler to check if the string is correct. What happens if you misspell the name of a JNDI resource? The compiler won't be able to tell. You won't know until it results in an error at runtime. I'd like you to think about how you would try to solve this problem.